think you're left. Better start all over.
No, we already went far.
That was the practice run. Let's go.
What? No practice run. We did election of officers. Jason from Peoria Sanitary is taking vice president. And Brandy from Galesburg has actually been doing, her and Jason been doing all our stuff, getting speakers and stuff. So we're always looking for anybody that can suggest anybody to come present to our group, so we can get these CEUs all done for everybody. I think Brandy sent out to everybody, there's some stuff going through with the EPA for different training. Problem is, we're not getting CEUs for them. Me and Jason were just talking about this morning. They're giving them for every other states except for ours. So you got to kind of persuade them to get numbers for us. I did watch a couple, and I can't remember who they came from. I think it was Illinois EPA on lagoons and stuff, and they were pretty good, actually. And they will send you the certificates and CEUs. I think most of them are about an hour long, so they're not too bad. But if anybody hears of any of them, pass them on to us so we can get them out to everybody, just so we can all get these CEUs done. Illinois Rural Water's got their conference coming up. When is this? February the 15th, I think is the first day, but most of it's for water. They got some wastewater stuff on the second day. So if you guys want to go to the conference in Effingham, that's available. I suggest trying to find the motel as soon as you can because most of them are booked up. So I'll have Kurt, you want to introduce and.
That's fine.
Sorry.
Great job. Got it.
Thank you.
All right. Good morning. Can they hear me okay like this? So my name is Hunter Hardesty. I've been with GasVoda about 7.5 years. It'll be 8 years here in October. I want to introduce John Maslowski with RKI. They produce all kinds of permanent and portable gas detection equipment for H2s, LEL, any kind of toxic gases that you might have in your water or wastewater system. John's been with RKI for 15 years now, I want to say, something like that. Maybe I shouldn't have said that, sorry. So without further ado, I'd like to bring John up and let him give his presentation. Thanks, guys.
Yeah, I think so.
Well, thank you much for having me today. The opportunity to speak with end users is something that RKI really depends on, and it's partners like GasVoda and Hunter that allow us that opportunity. Briefly, the opportunity for me to speak to you today, I wanted to make sure that it was broad enough that I want to elicit the questions that you guys have that you see every day. So what I wanted to do is show you what types of products are out there. I always like to point out that I've never walked a mile in your shoes. I've never worked in a water treatment facility or a wastewater facility. What I know is the technology that we use to measure the atmosphere. Now, I'm pretty good with applications, but where the opportunities really come is when you guys explain to me what needs you have, and then we as a manufacturer of the technology try to find a suitable product that will help you solve that need. So what I don't want to have happen is for me to talk at you. I'd rather try to encourage some questions that you may have, and feel free to ask those as we work through this. Because what I have found is every application that I do is different. And we not only work in water, wastewater, we work in power generation, we work in industry, we work in fire service. And the one common aspect of all those opportunities is all I do is measure the atmosphere. So when you tell me what you want to find, I'll tell you if I can see it, and then I'll quantify it. And then what we do when we quantify that is we send it somewhere. So if you guys are using SCADA systems and you need that delivered back to you so you can monitor it, or if you have an area that there is a concern about and something should happen if an elevated level should arise, we can activate a relay and we can turn on a fan, open a garage door, turn a light on, start a coffee maker for the guy that's got to come in and get to work in the early mornings. So this is about that technology, and what I'm going to take you through is where we use it and how we use it. So there's some slides in here about instruments, but more importantly, I'm going to teach you why it fails. When I speak to groups, mostly at the state shows, I used to talk about the basics of gas detection, and very few people would show up. What I decided to do is change the name of the talk that I gave to Why Gas Meters Fail, and guess what? A lot more people showed up. The simple reason is nobody likes gas monitors because they never seem to work when you need them. So if I can explain to you how they work and why they fail through a technological discussion of the sensors, it's going to make your life easier to say, oh, you know what? This makes sense to me, rather than, oh, this never works, and you put the meter back in your drawer. So with that, start thinking about questions or experiences you've had with other portable or fixed systems. Do any of you have digesters at your facilities? Show of hands. Okay. Are you using that gas to create energy, or are you just burning it off? Cogen at all? You do. Okay. Wonderful. Well, I don't want to not speak of it, but we do a digester gas monitoring product as well. It's very specialized, and it's becoming more and more prevalent. And what we do is we measure the gas that comes off the digester, one, pre-iron filter, and that's to make sure that you know what's happening in your digester from a health perspective, and then also post-iron filter, so we can quantify how good the gas is that you're going to burn to create that energy to put it back into the grid. So I'll speak about that if I have a little bit of time at the end, but if there is an itch, I will scratch it. Just let me know. With that, we'll get into the meat of this. So, both? I would be making a bold assumption, but I'm assuming everybody has both. I'd be hard pressed to think there's a treatment facility that doesn't. Many times I'll hear that, well, yeah, we've got them, but we need to have a little bit of work done on them. They need to be calibrated, or a sensor needs to be changed out. That's really a service that Gas Voda handles, and it's one that we train on, obviously manufacturer specific. But what you'll see here is the technology is the same across the board. So whether it's an RKI piece of equipment or maybe some others, a qualified service technician such as the GAI guys can probably get out there and help you out, because we're talking about atmospheric measurement. There's pretty straightforward. So as Hunter said, I've been doing this for 15 years. Prior to this, I did about 10 years in distributive sales. So I've got about 25 years of calling over a broad section of gas monitoring applications. Wastewater has always been a big one because it's always used. Reek and Kiki was founded in 1994. It's an offshoot of a company called Gas Tech. We still see Gas Tech products that are still in use today, believe it or not. It's a neat history, but RKI has been making those sensors and that sensor technology since the late 70s. And Gas Tech was actually a private label of Reek and Kiki, where we get the R and the K from in our name. So we've got a lot of years and a lot of experience. We are based in California. There's 10 salespeople like myself that travel the country. We set up distribution networks, train those networks. We come to the marketplace asking that you work locally with professionals so they can service you locally. And that's probably the biggest difference between what we do and what others do. There are opportunities to be had, but if we can't get the people out there to make sure your products are working right, it doesn't work very well. So we rely upon that distribution network and those trained service techs to do that. Ever-changing marketplaces, But what we'll find is we're going to categorize a couple different things for you. You're going to have a need, and what I want to teach you is, as I teach all the people in sales, is you got to qualify what it is. Now, we're going to first look at it and say, well, I have a portable need, and then there's a whole subsection of equipment that you can use. Then we have a fixed gas detection need, which is the placement of a sensor that would be in a room, on a wall, above a process, or for that matter, it could be a building security issue. You just want to make sure that gas doesn't accumulate in any given area. So when you look at your individual facilities, what I will challenge you to do is take a look at whatever the needs are and say, one, is it personal safety? And if it is personal safety, you're going to be looking at a monitor that a person will wear. That monitor is going to be designed to make the wearer aware of what is happening around them. OSHA's pretty good. We follow a guideline called 1910-146. It's not generic, but it's mostly for confined space entry, and it talks about personal safety. There is an obligation for employers to give employees that personal safety product so that they are safe while they do their jobs. So we do slide in under that safety umbrella. In that, what it is saying is, please wear these in your breathing zone. The idea is the instrument should be recognizing what the wearer is inhaling. So you don't want to wear a gas meter on your belt anymore, which I think is funny because the first 15 years of my life, we called them belt clips and we attached them to our belt. So recently in the last few years, they've said, well, looking at it, we're more worried about what is being inhaled, so we're going to place those meters up a little bit higher, 10, 12 inches of your breathing zone. Looking at the stationary gas devices or fixed systems, we can either look at it as a process control or we can look at it as building security, like a press. So if you have some gases that are coming off your presses, you can put a stationary sensor in that room and it will monitor it. It'll make you aware of what's happening during that process. Now, if it's less about the process and more about the area, oftentimes we'll end up placing what are called LEL sensors or lower explosive sensors. They measure the amount of CH4 methane gas in the air, and you'll put that higher up in elevation in your building because it will rise. And we want to make sure that the building is safe and secure. So that becomes a building security issue. But as we all know, the influent that you guys get sometimes will have heavy hydrocarbons in it. So we do a lot of work in lift stations. So the lift station will have a combination of both CH4 light molecule chained hydrocarbons and some heavier ones. We never know what people are going to put in the drains, right? So oils, heavy long chain molecules. So we also measure lower in lift stations, but we always want to be careful about the placement of those because they are electronic, and if they get submerged in water, they will not work. So again, each application is different. Each of your applications will be unique. As we scratch the surface of the equipment and how it's supposed to be placed and where it's supposed to be placed, I will encourage you to reach out to a professional, discuss the application with them, and then they will guide you through the opportunity to choose what best fits your needs. I'm going to go through a slide later on that will really define how many different ways we can monitor a particular area. And it's pretty interesting because a individual will have a suggestion for you. You can have this another person come in and look at your application, and they may suggest something a little bit different. There's a lot of ways to skin the cat, if you will. So keeping that in mind. So how does a gas detector work? These are all pictures of different packaging. The one thing that we have that's similar is inside of each of these packages are the sensors themselves. And a sensor is a fuel cell. For instance, this is a controller. This is going to give you a readout of a sensor or fuel cell which is attached to basically a J-box, but you would place that somewhere in your facility. Obviously, the sensors, you have sample trains that brings the sample into the unit. This will measure locally, or this will measure right at the point where the air is being sucked into the instrument. This is called a diffusion monitor. The air will transfer through a hydrophobic filter right here, and it will give you a representative indication of the atmosphere in and around you. There is not necessarily a plus or minus to using a sample draw instrument versus a diffusion instrument. Again, we're going to take a step back and we're going to look at the application. The simplest way to put it is, if you are going to be going into something, you want to pull a sample out of it before you enter into it. The easiest way to do that is to have a unit with a pump on it to pull that sample, because you want to make sure that there's good air in there before somebody takes a step in. Once you've done that, you just have the individual wear a meter on their lapel, and they will be good to go because it'll be measuring them. So we call that breaking the plane, and the best example I have of that is a manhole. Nobody goes into a manhole before they test it. That should just be common sense. In doing so, we'll talk a little bit more about what happens in that manhole later on. But not only when you talk about manholes, but what about a vessel? It's the same thing. Anytime you walk into a room that has a door, no HVAC in it, that is a potential hazard if there's something in there that might cause a problem, like a tank of chlorine. So we want to be sure that people aren't walking into things without measuring them if there's a potential hazard behind the door. And that's effectively what these will do. Confined spaces, the 1910-146, it's all of a paragraph long, and it's ambiguous at best. And it can't be specific because they have to touch every industry out there. And what they do is they rely upon the safety professionals in your facilities to evaluate your confined spaces. And then you have to figure out how you want your guys to enter that. Now, there's a lot of classes out there. There's a lot of teachings out there. The one common aspect to those is you got to test that air before somebody goes in it. And that is the most important. How you get into it, that's going to be left up to you and the protocols that you set for your employees. What I train people on is the technology. When my sales guys come to your location, they may or may not, depending on their disciplines, be able to teach you how to get in and out of those confined spaces, but that's not my job. I stay away from that. So I am strictly a small part of a larger picture of safety. For instance, when you have a tripod, you should have a winch, a man winch and a work winch. The person that's using the tripod needs to have a harness. Well, if they have a harness, that means they're going into something. There's a very small part missing in that, which is the common package. You got a tripod, a winch, a work winch, and a harness. Where's the gas meter? I'll challenge you when you look at those packages that people offer. Oftentimes they're missing that gas monitor. But it is a piece that needs to be included in that package. So again, we're a smaller part of a larger picture, and keeping that in mind is always going to be good for you to do. Can you smell hazardous atmospheres? Heck yeah. There are also gases that are of great concern to us that you can't smell. Obviously, hydrogen sulfide, rotten egg smell. How do you quantify it? Well, I'll tell you, this is your best gas meter in the world right here, your nose. It works great, and it'll measure in the part per billion, but you really can't quantify it. I live in Wisconsin. I call it the barnyard effect. Boy, after a while, I don't even smell the cows. Why? I just get used to it. So in the same way, when you walk into your facility or there is an exposure, we have to be able to quantify it and we have to do it accurately. The only way that we can accurately measure these hazards is through a technology. So even if you haven't worn one in 30 years and, I don't need to do this, all this new equipment, it's a lottery ticket. You want to make sure that you are protecting yourself from what potentially may be there. So with that in mind, you can smell them. What about other opportunities? And here's my picture of that manhole. Methane. Can you smell it? Some people say they can, but generally, methane that we can smell has been odorized by our gas companies. They put what are called mercaptans in it. And that's what we associate with natural gas. But gas that comes from the cows and that comes from us and other naturally occurring ethanes, Generally, you cannot. And where do they reside? Well, in this manhole, they're lighter than air, so they're going to rise to the top, but we often put a cap on top of those manholes. So that's great. Methane rises to the top. Heavier hydrocarbons with longer molecular chains, they'll sit at the bottom. Those oils and those diesels and those other hydrocarbons, they all explode. So hydrocarbon is a hydrogen and carbon molecule crammed together. All that means is it's going to blow up at some point. Heavier gases, carbon monoxide, it's about the same as air. It floats like a cloud. Well, carbon monoxide is equally as bad, probably worse than the methane that you'll see. The public service announcements in the fall when they come on TV and they say, hey, please check your furnaces. Make sure they're venting properly. That's because they call carbon monoxide the silent killer. If your furnaces don't work right, it'll just fill the house up, bottom up, because it's heavier and it floats like, well, it's not necessarily heavier, but the molecular weight of that will create a cloud and it'll just fill up that house. And while you're sleeping, you just won't wake up. I hate to say it, but it's still a very popular way for our teenagers to kill themselves. And what do? They put their earbuds in, they go into the garage, they listen to their favorite music, and before you know it, they've gone to sleep and they don't wake up. And it's tragic. That's carbon monoxide gas. And it is everywhere where an aspirating gas engine would be. So keeping that in mind, carbon monoxide needs to be quantified with a sensor. Hydrogen sulfide, it's heavy, and it'll reside back on in the lower areas of that manhole. So when you go into a manhole, if you're using a unit with a pump, the opportunity is, hey, lower that hose down into that manhole or into that space that you're going to enter into. But if I drop that line all the way to the bottom, I'm skipping through a stratification of that sphere of influence. It's not going to measure methane because you've blown right through it. So whenever you enter into or you measure a space, you want to do it incrementally. I'll say 4 or 5 feet. Anybody can venture why they say 4 or 5 feet? I'm not vertically challenged. I'm a little bit higher than 4 feet, but guess what? I'm about 4 or 5, well, I'm 5.5, 6 feet tall. So every 4, 5, 6 feet, you want to take a measurement. One, so you can capture the methane, you can capture the carbon monoxide in the air floating around, and you can drop it down low, and you can measure that hydrogen sulfide or those heavy hydrocarbons. You want to make sure that you measure the whole atmosphere prior to entering into it. So it's not just, hey, pull a sample, I'm good to go. You got to incrementally measure in that depending on the depth of it. So good walk around information for people that are going into areas, one, that they're not used to, or if it's only a place that they go, perhaps a lift station once every quarter, once every 6 months. They have to be aware those protocols will be very important. The opportunity for people to wear gas detection has become super important. What you're going to find are units, and I think some guys are passing them around. There's one. What they've designed now is the smallest and lightest meters in the world. They don't want them to interfere with the work of the individual. Let's be truthful. Guys don't walk around and listen and look at their meters all day. They got a job to do. We used to wear them on our belt. Now we've been asked to put them up here on our lapel. That's fine. And in that, we have an obligation to just let them be. And they will alarm, they will flash, and they will vibrate. And in that, it will make the wearer aware of any potential hazard, and then they would take the appropriate actions to get out. Oh, I'm moving around too much?
Right there. Perfect. Have you ever had issues with someone putting the meter right here, their breath causing the meter to go off or something like that? Maybe exhale, you know what I mean?
Yeah. It's a great question. The question was, if you wear the meter too close to your exhalation breath, will it cause a problem? Generally not. The reason for that is we exhale carbon dioxide, and we measure for carbon monoxide. Those sensors will specifically only measure for the molecules that they're intended to. Now, I will be the first to tell you that if you're wearing a welding hood and you're kicking it and you're in close contact and you've got a lot of those gases from your welds coming up, we do see that. Welding falls under a whole nother category of measurement, I guess I would say, and you have to pay a little bit closer attention to it. Sometimes they'll mitigate those gas risks by putting ventilation in the area, but generally not. And that's a great question because each of those 4 sensors, as we'll talk about, are independent of each other. They will only measure for the target gases intended. There are some small cross sensitivities that we'll see with LEL gas detection, but we will get with that. So different models, different uses. I put these up here, one, because this small one is 3.2 ounces, lightest and smallest in the world. It's just going to sit there. It'll notify you if there's a problem. What if you're working alone at night in your facility and your obligation is to go out and check some security boxes? They have what is now being called lone worker. And what lone worker is it gives an opportunity for the device, in this case it is Bluetooth, it'll communicate with your phone. If there's ever an alarm or an issue, it will communicate with the phone. It'll send an email and a text to any supervisor that you want instantly upon that meter going into any type of alarm. Not only does it measure now for the 4 gases, but it will do a man down. So for instance, what if it's not a gas emergency? What if he has a heart attack? Well, the little accelerometer in it will see that he's motionless, fire off that email and that text to get help along the way. That part of the industry is sort of like a wave, and that wave is building, and we refer to it as lone worker. So right now, the most of the units that we see are just the traditional 4 gas, but what we're seeing is the advent of the technologies that are accessible to us and the cloud-based reporting and things like this. It's pretty amazing, and you're going to see a change in our industry for the most part that's going to bring us towards that. If you do have a concern about lone worker, just talk to me afterwards. I can explain to you it a little bit more. That's a little bit more than comprehensive. So what do we have here? Well, if you ever have an opportunity where perhaps you have to measure for ammonia or chlorine, how do you do that? Those little 4 gas meters don't. The larger meters do. We have sensors that we can put in there and we can measure those target gases for you. CO2, because it was brought up earlier, we would do indoor air quality in a building like this. HVAC contractors measure for CO2. Why? Well, when it gets to be elevated, they call it sick building syndrome. People get sleepy. It's not that they're tired of work, it's just that they're being overcome by a larger amount of carbon dioxide and other gases that make them sleepy. Sure, cups of coffee work great, but what they need to do is train the atmosphere a little bit more, and you'll get a better quality of air. So CO2 is becoming very prevalent. VOC, volatile organic compounds, that's more of a hazardous materials type sensor. A lot of your hazmat teams will have it, but if you find yourself with something that you don't know what it is and you need to quantify a potential hazard, that's what we would use VOCs for. I don't really see a great need for it in water, wastewater, but it is a sensor that can be plugged into this device as with many others. Now I've seen ammonia, chlorines, those are probably the 2 most prevalent that I see in water treatment and wastewater, along with the standard 4. Are you guys using any other sensor technology beyond those? No? I've been talking quite a bit. Any questions so far about what I've shared? And then the people online, you can send through a text, and those questions will be monitored by the host here if you like. Boom. We'll get rid of that. Again, one of these meters is floating around. The reason I put the slide up is not only do they do confined spaces, because they measure the atmosphere for personal safety, but we use the same instrument in pipeline gas for purges and blowdowns, making sure that the gas that gets pushed across the country doesn't have air bubbles in it. Comes through a compressor station. If that thing hiccups, they got a big problem, right? So all that gas not only gets pushed across the country, but it gets pushed to ComEd, it gets pushed to Nucor, or Nicor, I should say, and then they take hold of it, and then they distribute the gas to places like this that heat the areas for personal consumption. We also do it for leak check, flanges and things of that nature. We can measure down to the part per million in gas detection. We then measure percent LEL, which is used for personal safety to make sure that we don't blow up. You'll like to know that not often do people blow up. It's probably one of the least reasons why there's a incident, although it's the one that shows up on the news most often. If it bleeds, it leads, right? And then borehole sampling. This is pretty consistent with like landfills. They want to make sure that leachate gas doesn't sneak out of the landfill. Make sure that they're pulling that gas back to the flame or to the flare to burn off, or for cogeneration. So again, one tool will do all these different things. And it makes my job easy because I only have to teach people one product, but yet those are all different applications, some of which affect you, some of which don't. So I'll oftentimes get a call from somebody and they'll say, hey, I've got this concern, and they'll already have the tool that will help them solve their problem. They just have to recognize that atmospheric measurement is just that. If it's an LEL or if it's a combustible concern, you must probably already have that instrument that'll help you. So there's no reason to keep buying new instruments when the things that you have may already do the job for you. So that's portables in a nutshell, and now we're going to move into common fixed systems and really how they are designed. Most everybody will deliver signals back to a SCADA. Is that pretty common? And then every once in a while, we'll find people who just want to have a localized alarm. They'll say, hey, I'm just worried about this building. I need to put a light outside the door to make sure the guys know not to go in there if there's an exposure. They don't deliver that signal to a SCADA, and that's fine, but we can accommodate both. All it is different degrees of how much equipment you need. The most basic fixed system is a small controller, and this controller will have a readout, and it'll tell you what is being read by a sensor, and that would be this one. And this sensor can be close or it can be far, but this is the most common fixed system that you see out there. If it was a room that you wanted to monitor, you would put the fixed system inside the room. You would connect it via wire to this controller on the outside of the room. On this controller, there's a little buzzer, and if you want, we could put a light on it. The people know that they should not go into that area if either is elevated, the buzzer's on, or the light is flashing. If you wanted to take that information, send it to a building security, each one of the controllers has a 4 to 20 milliamp out. Any standard security system will take that. Any fire panel will take that. Your SCADA will take that. It really is just a conduit by which you can send information. It's got relays in it. So if you have a relay and you say, yeah, if I see a little bit of elevated level, hey, turn this fan on. Let's blow this stuff out. And then you've mitigated the occurrence altogether. Now this is all done sight unseen, right? You set it and you forget it. And you know that those atmospheres will all be good, and it becomes one less thing to worry about, except when there is an alarm, you'll be notified in some way, shape, or form, probably through an employee. What do you need to do? You need to calibrate them. We'll talk about calibration later when we talk about sensor technology, but that's the idea behind a fixed system. Notification if you want it, and or to mitigate potentially hazardous atmospheres if one occurs in areas that potentially have hazards. Questions? We're going to talk about molecular weight of contaminants again, but placement of the sensors themselves are all based on the molecular weight of the target gas that you want to see. So we have a direct connect sensor, low cost, an S2 transmitter. What does that mean? Well, if it's a great distance, I can use a transmitter to create a 4 to 20 milliamp output right at the head. And what that means is I can calibrate this whole system from here. With a direct connect, where there's no transmitter, I have to push buttons on here, then I have to walk over to the sensor and I have to calibrate it, then I have to walk back to the controller and I have to accept the calibration. So if it's a short distance, I really like direct connect sensors. They're a little bit less expensive, and if it's not a pain in your butt to work on, it's a great way to go. But if you're 2,500 feet away, you don't want to be running back and forth. You just put a transmitter in place and you walk out to this with a voltmeter, some calibration gases, and you can do everything at the point of gas detection. So John, that's great, but if I'm out in that room, there's no LED display on it. I don't know what the hell's going on in that area. Oh, we got a fix for that. It's called an M2A. It's got a little digital display on it. It'll do the same thing this does, but it'll tell you how much gas is there. It'll then push that signal back to the controller as well. So all we're doing is we're adding a feature to the gas detection sensor head. So if it is really important that the guys in that area know what they're facing, use an M2A. If it's not, don't put the display on it. Just use a sensor transmitter or a direct connect. Another good question is this. Hey, if the LEL gas is up in the ceiling and that's where I want to measure, every time I got to calibrate it, do I have to get a lift to go up there and do it? Yeah, pretty much. Unless you take the small step of adding a remote calibration adapter to it, and then you would drop poly tubing down to the floor, and guess what? Now you don't have to get a ladder out, you don't have to get a lift, you don't have to do it. There's all sorts of ways to skin the cat, and these are what the professionals are going to do when they come out and visit you. They're going to look at that application and they're going to say, all right, we're going to make this easy. So what doesn't happen when you guys design your new plants? Well, usually the engineers will copy and paste what's called a master spec, and they'll say, oh, I need gas detection in this room. Click, drag, paste. How often do those work out for you? Not very often, right? Because it usually says, oh, we need a gas monitor in here. Okay, what type of gas monitor? You're going to have to direct whoever it is that installs that equipment in your facility. You're going to have to tell them what you want, and it has to meet your needs. So if the guy says, oh, well, we just picked the cheapest one we could get for the spec, and they give you a direct connect sensor, but it's 2,500 feet away, that electrician's going to be pulling wire forever. You got to calibrate it. It's going to be a pain in your butt. And all you need to do is talk to somebody like Hunter, and he'll come out and say, hey, you know what? Let's talk about making this easy for you in your new facility. And he'll put together a parts list for you. You can send that back to the engineering firm. They can put that in the spec. That spec goes out, goes through about 15 different hands, and somehow equipment shows up at your place. So this is what our desire is that you're always touched by a professional who knows a little bit more about gas detection than a copy and paste off of a master spec. So keep that in mind if you're doing any construction, or you're planning on any construction. It may be a very, very small monetary piece of an overall huge project, but it's one that you guys are going to have to pay attention to, and it's a maintenance item. It's not a silver bullet. You do have to calibrate these things, and they are designed to keep your guys safe. So put a little extra effort into it when you're looking at it. It'll make a great difference. So why? Well, O2. 20.9 is the atmosphere that we live and breathe in. How many of you guys are mountain climbers? I love this. They have this thing on Mount Everest. Yeah, how many of you guys watch the show on Mount Everest? You had a National Geographic. So they go to base camp. Yeah, okay, great. And they stay there for a month. Why do they stay there for a month? They have to acclimate, right? They have to get used to the thin air. Thin air, what the hell's thin air? It's not 20.9 oxygen. It's it's less than 20.9. So they need to acclimate so they can actually function. Well, then what do? They strap on, I don't know how many pounds, and then they climb a mountain. And they get to this little thing. It's called, Hillary was one of the first climbers. It's called Hillary's Notch. Up above that, guess what they call it? They call it the death zone. So about 40% of everybody who climbs Mount Everest dies. I think that's about right, 40%. So pretty good odds, right? You're voluntarily climbing Mount Everest, and you're paying somebody a truckload of money to do it, and they're taking you to a place called the death zone. Well, the death zone is about 12%. And we can create death zones very easily in confined spaces, and that's by adding other gases to the mix. It pushes out the oxygen. And at about 19.5 is where the alarm goes off. Well, increased pulse and respiration. Wonderful. I can tell you when I climb ladders and I carry tools around, my pulse goes up and I start to perspire a little bit. So how is my attendant going to know if I'm just out of shape or if the Packers lost on a Sunday and I drank too much and then Monday came around and I really didn't feel like working and I had too many cheese pops? I mean, I'm going to be sweating like a dog. Does that mean that there's not enough oxygen in that hole? Hell no. There's no way to know unless you quantifiably measure it. But what happens? Well, you start to get to a place where you start to make really bad decisions. Like, oh, I'm almost done with this. I'm just going to, one more wrench turn, and I'll have this motor mounted. Or you become a little clumsy and you drop the screwdriver. Well, now you got to go get the screwdriver. Well, what do you mean? You got to go bend over to get the screwdriver? Sure. Remember that picture of all the stratification? If we know that oxygen has been compromised, it's being compromised by something. What if it's hydrogen sulfide? What if it's carbon monoxide? You never know. But if you duck down to pick something up and you hit one of those stratification levels, if the gas presence is greater than X, you could be in big trouble. So that's why we have an attendant. It's their job to watch you down in that hole to make sure you don't have a problem, but you got to be measuring that hole because we all sweat when we work. So you get to this point, you're in big trouble. You're probably going to be voluntarily retiring from your job if you find yourself, you're not going to be right. And it's not a good place to be. But oxygen is probably the most dangerous gas that we will ever come in contact with. And I say that in all truthfulness. Silos up in Wisconsin, the dust will push the air out of the silos. And what do the farm kids do when the silage gets stuck? They go on top, and what do? They jump up and down on it. I mean, really? So not only is it entrapment, they might suffocate to death and squeeze themselves to death, but the dust will push the air out of the way. Now, that's in agriculture. That has nothing to do with where we're pushing influent through the bottom, where the opportunity for CH4 from methane gas is always present. The hydrogen sulfide from decomposing organics is always present. And, oh my God, there's things called automobiles that drive over the top of all the manhole covers. They all push out carbon monoxide, and they're about the same molecular weight as air. So if there is any forcible current of air going anywhere, it's always around us. It's very, very dangerous. So that's O2. How does this sensor work? Well, it's a fuel cell. And in my fuel cell, that sensor has fuel. And once I start making it, I have an oxygen molecule, and it comes right through the top. When that oxygen molecule hits this, it creates an electrical output. Boop. So as soon as I make it, it starts working. Well, if you turn off your meter, John, does your oxygen sensor stop working? No, sir, it doesn't. The oxygen sensor will be the sensor that drives you guys crazy. This thing always fails on me. Well, yeah, it does, because you guys want really small, tiny instruments that don't weigh anything and that aren't going to be a pain in your butt. So we have to make really small sensors that have that electrochemical solution in them. And they're about the size of a nickel, not even a nickel. I don't know if you can see that. But this is what we put in those monitors. Now, I can tell you that the sensor technology is really good, but the longer this stays out well, since it's made, it's going to last 3.5, 4 years. Now, why is there such a disparity in those? These sensors right here are from an older product that we make. We're still making it today. I warranty that sensor for 2 years. Okay, great. The 2 years is pretty good. I know it'll stay that way. I expect it to last 3.5. That's the land of the warranty, right? My newer technology, it's a little bit different. Science is really good. We always improve upon things. I have a new sensor which allows us to increase our warranties to 3 years. I expect that sensor to last 4, maybe even more years. Now that's pretty good, all things considered, because in the old days, all people did was complain about their O2 sensors failing. And the simple reason was, as soon as the electrolyte here, as soon as it's gone, the sensor fails. It has nothing to do with showing it more or less oxygen because it's always seeing 20.9. So it never stops working 24/7, 365. Hence, oxygen sensors are most often replaced first. Right? We do have to calibrate it. Why do I have to calibrate it? I'll go more into depth. But if I do a fresh air calibration with a full cell, I know what 20.9 output looks like from an electrical point of view. If I challenge it with a gas, I then know what that output will be as well. I draw a linear line between good and bad gas. If in my equation the only thing that changes is this electrolyte, as this decreases, I will have what's called drift, and that drift is inaccuracy. So we want to make sure these things are accurate. So I relinearize the sensor. As this decreases, every so often we need to relinearize those outputs so I know it's accurate, because we are always using that fuel. And that's an oxygen sensor. That's how, for the most part, everybody's oxygen sensor works. Not just mine, but everybody's. Are some better than others? Yeah, I think so. Do some have better warranty than others? Yeah, there are. But for the most part, they are all the same. Who's had problems with O2 sensors? Yeah, that's why. That's why they fail. Hydrogen sulfide, H2s. How many of you guys, I don't want to say have an H2s issue. How many of you are aware of your H2s? Or you need to be aware of your H2s? Do you have any locations in your facility that H2s potentially is an issue? No? Yeah?
H2s poisoning, besides me. Anybody?
Have you? Yeah, that's not good.
Twice as bad as food poisoning. Serious.
Yeah, that's bad. So,
Like our pre-treatment building and stuff, where the walls stuff.
yep. Yep. A lot of it will have to do with the type of day it is. A really hot, nice, sunny day with no wind, sitting out, man, that organic material will just cook. Those are the dangerous days. Days where it's nice and windy, nah, not so much. Why? Because you're evacuating the air. You're turning that air in the environment. You're not seeing it collect, right? So, yeah, it's always there, but a lot of times nature and the wind and the environment will help us out. But if you have a closed up area of influence, like a lift station, here we go. Now we have a concern to be aware of, especially on a really hot, nice week where we get here in the Midwest, a month where it's like 90 degrees and that stuff just cooks. So be aware of it. Now, it is heavier. What is it? It's a decomposition of organic material, so poop. What about leaves? Are they organic? Spring and fall. Where does everybody push their leaves? Right down in the sewer, right? What about that big fat raccoon? Yeah, he dies down there too. Squirrels, rats, dogs, cats, you name it. Anything that is once living, after it dies and the water and the air get after it, it gets nasty, and that is your hydrogen sulfide. It is flammable. Here's a good one for you. What's the difference between an explosive gas and a toxic gas? Just, not that I expect anybody to belt out the answer, but we call a toxic gas something that kills you before it blows up. We call an explosive gas something that explodes before it kills you. A great example of that is ammonia. Why is that a toxic gas? Because it'll kill you dead before it blows up. But man, if that thing blows up, giddy up. You got a big explosion. So where do we use ammonia? We use ammonia on your fields. They use it as fertilizer. Big tanks of it, and they spread it all over the place. When it rains, where does all the rainwater go? Right in the ditch. Where does all the ditch water go? Right to you guys. What else do we use ammonia for? Do you guys got a big food store over here? Distribution center? Big, huge tanks of ammonia. They use it to refrigerate all the freezers. So there's an example of, I only measure for ammonia. I don't care what the application is. I can do it in a food store. I can do it in a farmer's field lift station. Had the opportunity to go out to Pioneer and look at one of their lift stations. Whew, that's nasty. They do a lot of research and development with fertilizers and things. Interesting call, but a good call. The effects, rotten egg smell. Here's the important part. Right about here, we lose consciousness, right? 250 to 400 parts per million. But at 100 to 200, we have that thing called the barnyard effect. Hey, I no longer smell hydrogen sulfide. Well, that's wonderful. That's because it's killed your olfactory, I think that's what they call it, the olfactory senses. You cannot smell it anymore. And it's getting worse. But you don't think it because you can't smell it anymore. So the only way to look at it is to quantify it. Well, what happens at 1,000 parts per million? One breath, you're dead. Just one. Do you guys have any lakes out here? Lake communities with restaurants? Yeah? So a lot of times the restaurants will have holding tanks. And they only pump out the holding tanks like once a week. Right? And then they send all that to you guys. Have you ever noticed how the concrete's always eaten out in those familiar areas? That's hydrogen sulfide gas eating concrete. And they send that to you. So, is the opportunity for hydrogen gas to be present in your facility? Hell yeah. Especially after it sits in a nice hot holding tank for a week out by the lake. So, it's pretty serious stuff. Sensor, same way. Electrochemical solution, the H2s and the CO are set up the same way. As soon as the molecule comes in contact with the solution, it will create an output. So it is cause and effect. If there's no H2s, there's no reaction, there's no output. Now the H2s and CO sensors are totally different. This is a little bit misleading. It makes it look like they're one, but the two sensor technologies have two different electrolytes in them, so they won't respond to each other, but we do put some filtration in place. So with that said, my H2s and my CO sensor is going to last longer than the O2 sensor because the O2 sensor works all day long, every day, 24/7. How often do we see CO? More so than we see H2s. So then the general effect is your CO sensor will fail before the H2s. Why? Because it's not seeing it as often. We're not using as much of that fuel. So O2, CO, H2s. And that leaves us with electrochemical sensors and cross sensitivities and things like that. We take care of those with filtration, not really to be concerned about in your applications. But that leaves us a combustible gas, flash point, fire point, ignition point. These are all things that are specific to each and every hydrocarbon. I don't know if you guys have ever looked at a hydrocarbon list before, but we all know what methane is. When you write CH4 down, some people look at it a little strange, but that's how scientists write CH4. Sometimes you'll see a C with 4 little lines and H's around them. That's another way of writing CH4. Well, it blows up. So does propane, right? So does hexane, nonane, decane, toluene. These are all different molecular chains of hydrocarbons. Well, what about gasoline? Well, gasoline is a product. And in gasoline, they have benzene, toluene, xylene, or BTEX, benzene, toluene, I forget exactly. But so we make things that become explosive as well. Diesel fuel is explosive. And if I had a puddle of diesel fuel and a puddle of gasoline on a hot asphalt, what generally do you see when you think about it? You spill a little gasoline when you're cutting your lawn in your driveway. You see the fumes come off of it. But if you had a puddle of diesel fuel right next to it, it would just sit there and not do anything. They're both hydrocarbons, they're both fuels, they're both going to explode, but there are physical differences between those two products. So whenever you're working with combustible gas, you have to know what that target gas is. For the most part in wastewater treatment, it's always CH4 methane. While for my other customers that perhaps they're a construction company, they got to know if they're going to see propane. There's a lot of propane fields out there. There's a lot of propane used here. A lot of products like toluene, which is a thinner that's used in ink, so anytime they do printing. Those are all concerns. That one sensor that you have in your unit, that will measure all of those. It doesn't speciate, but what we do is we calibrate it to methane so we see it at a 1-to-1 ratio. Is it going to still see your heavy hydrocarbons that are down in your lift station? Yeah, there's a great potential that it would, but it won't see it accurately. So if you're really concerned about it because you got an industrial plant and they keep pushing stuff down there and you keep yelling at them and your superintendent yells at them, but they keep doing it, we may calibrate an LEL sensor for CH4 methane and put it up high in the lift station, but we may also use that same sensor and we may place it lower and we would calibrate it to maybe isobutane or hexane so it will see gasolines and fuels and heavy hydrocarbons that come through. There's all sorts of things that we can do technically for you guys to help you understand what best is coming into your plant so you can mitigate those things and keep your personnel safe. So, for instance, just to give you an idea, if this room were completely closed off and let's say I'm a pipeline guy, if this room was 100% full of methane gas, it would be as if we were inside a pipeline. That would be 100% by volume. The whole room is filled up with gas. Percent by volume is a unit of measure. So percent LEL, percent lower explosive limit, is a unit of measure. And at 5% volume is 100% lower explosive limit. So let's think about this visually. If the room is 100%, if I go to 5%, which is about right here where my arm is, right? If this much of the room is filled with CH4 methane gas, guess what? We blow up if there's a spark. Pretty interesting, huh? So when we talk about LEL, we also have alarm set points. And in that 0 to 100% LEL, at 10% LEL, I set an alarm off and I say, hey guys, you got an exposure to gas. You need to be aware of it. You might want to mitigate it. Then we have a secondary alarm, which is 50%, halfway to the point where the atmosphere is explosive. So this is where we live in LEL. And this is what we measure to keep ourselves safe. And that's the importance of it, because we know how much gas is around us. And that's the importance of people wearing the meters to give them an awareness. And then actually the areas within your facilities to place that sensor to make sure you know if you are in increasing atmosphere of LEL. Because if you get to 5% by volume or 100% LEL, you're going to have, Calumet did it a couple years ago, didn't they? They blew the whole building out. Yep. It happens. Doesn't happen often, but it got playtime on the TV. So that's LEL combustible gas. Too rich. Gas is like a carburetor in a car. We measure 0 to 100% in here. At 100%, we become explosive. Up here, it's too rich. I always use a carburetor. My car, my first car, it never started, especially in the winter. So I'd pop the hood, I'd jam a screwdriver in the carb, put more air in there. All I was doing is creating an explosive atmosphere. Sometimes squirt a little something in there to make it turn over. So personally, we try to stay here. For the guys using digesters, you are going to want to be in the upper UEL area. You're going to want to have as much gas as you can. Usually about 65 to 67% by volume coming off your digesters is where you guys want to introduce that gas to your engines for cogeneration. And we measure this as well as this, all in the hopes of not getting this. So other opportunities, I mentioned methane. 12% by volume, it'll blow up. But it'll kill you way before it blows up, so we call it a toxic gas. Methane. Hydrogen is becoming very prevalent in the community. Hydrogen cars, remember those? And then hexane, it's just volatile. Propane. Why do we use it for cooking on grills? Because it's more volatile than methane. Works better, burns hotter. So all these little things. Important definitions, they're all over. What do we need in order for an atmosphere to blow up? Perfect. If we don't have oxygen, it can't burn, it can't ignite. Inert atmospheres. Or if there's so much air pushed out of an area, it won't ignite. But then we run into a problem, we can't breathe. So these are all things that we take into consideration. We don't need photoionization. We have tools that measure LEL, ppm, and percent by volume. The assortment of what package you choose are all going to be defined by what your needs are. Do you need to pull a sample a great distance? If you do, you can use the yellow instrument. It'll pull a sample 150 feet. That one is almost uniquely used now in refineries, in inert atmospheres. These little guys are used primarily for people, and the fixed systems primarily for process control and building security. Calibration, super important. It's not a magic bullet. Because you guys know how sensors work now, please recognize that on a fixed system, you're going to want to calibrate it probably twice a year. If the environment is really harsh and you're constantly exercising that sensor, you may want to calibrate more often. It's a really bad question to ask me because I don't know anything about your building. Never walked a mile in your shoes. John, how often do I have to calibrate this? I don't know. How would I know? Why would you listen to me? These are all conversations you have with the professional that sells you the equipment. Why are you putting it in here? Why? Did you have a problem? Nope. Do you normally have a problem? Nope. Okay, you could probably back off on calibration, but you're going to have a history. You'll know how much degradation is on that fuel cell pursuant to how often you calibrate it and how much correction is needed to be done to that when they relinearize the sensors. So you'll grow through historical documentation to know how long your sensors are going to last. If you put an LEL sensor in a lift station that always has LEL in it, it's not going to last as long as we're in an area that did have a lot of gas in it, right? So again, the salespeople that we send out to you are supposed to listen, not necessarily sell you, but what our plan is that they become not consultants. You don't pay them $250 an hour to drive out there, right? But they're going to listen to what your needs are, and they're going to make suggestions as to how you could mitigate the circumstance you're in. And it becomes very simple. Yeah, you need portables. Sometimes you need both. This is that digester monitor. It's pretty slick. Not only do we use it to measure what's happening in the digester as you take loads, it will tell you what's happening. It's like a stomach, right? That digester. And it will tell you when it's upset. And you can change what you feed it. And then you can settle it down. That's really important nowadays because it all is a determining factor on what quality of gas you get on the backside after you filter out the H2s. So you can burn the fuel to make energy to put money back on the grid. This is a very interesting application, and over the last 5 to 8 years, whenever the federal government decides that they're going to throw cash at it, a lot of municipalities take advantage of it, and they're putting energy back on. A lot of times there's a cogeneration credit. They say, hey, 25% of your, you got to be able to put 25% of your energy back through cogen. California's crazy about it. Midwest, we're getting there. They'll take wastewater waste, and now there's even private companies that are taking food waste, rendering waste, and they're building out infrastructure to accommodate that. Because those organics all break down, they put bugs in it, the bugs create gas, and then that gas makes energy. Waste management does it almost everywhere. They make more money putting gas back onto the marketplace than they do taking loads of garbage now. They're just being provided fuel to make energy. They're an energy company. They're not a waste company. It's pretty amazing. Reference materials. I like CDC and NIOSH. NIOSH is a really good one. They got NIOSH chemical hazards. You can look up anything. It'll give you flashpoint, LEL, specific gravity, vapor density, and it'll give you hazard identification. Pocket guide to the chemical hazards. If your fire department guys, they're good. They carry a lot of knowledge with them. And in that knowledge base, they're going to also be a good point of reference for you. So reach out within your own communities to find out people who are using it. Most of the municipalities have it. But if you have a level A, which I don't think, this is probably a level B fire fire community? I don't know where your level A hazmat team, anybody know where your hazmat team comes from? They have a level A hazmat? The wealth of knowledge. Their fire marshal or the lieutenants or who not would come out. Always a great resource. Always a great resource. They know all the gases of all the companies within their area because if they get a call, they got to know what they're dealing with. So those guys are always very learned. And again, all we're going to do is measure those atmospheres, deliver those signals back to you in whatever form that you want, with the intent and purpose of keeping persons safe, processes safe, or buildings safe. So if you guys divide what your needs are into those three categories, it will direct you into the type of equipment you need. And then once you get that category of equipment, you can look for small and light. You can look for a unit with a pump. You might need something with a little more oomph on it. You might need something that will do ammonia, chlorine. Those are the questions that we can help answer and get you questions for. So I talked a lot. I stayed right about an hour, which is pretty good for me because I get paid to talk. I just don't tell bad jokes. Do you guys have any questions? Or are there any questions that came through on the internet? Yeah.
You go in a manhole, we use the meter with a pump on it. We got our company guys up on top, and we measure down so far. Person going in, we don't have a monitor on them. We're constantly monitoring the pump unit up on top.
Yeah.
That's still good. I mean,
Well, I don't tip my toes into the procedural workings of how people choose to go in and out of those because, one, I don't. I can share with you that when you read the guidelines for entering into a confined space, they're going to say you cannot break the plane of that until you measure the atmosphere to make sure it's clear. You do want to continuously monitor it, and if you have a unit with a pump that's pulling a sample, that's great. The one caveat I'll throw at you now is there's a recommendation out there that anybody in a potentially hazardous atmosphere be wearing meters within their breathing zone. So the reality is that tube going to be dangling within 10 inches of their breathing zone? As a recommendation? Come on. Okay, the favorite thing that I hear is always, oh yeah, I got a general duty clause. Well, for what? Well, I don't know. It wasn't a written spec, but he said, yeah, this is something that you needed to pay more attention to. They're usually mitigated pretty quickly by purchasing or training and things of that nature. But there is an intentional ambiguity to it because they're going to ask you as the owner of that space to do the right thing for the safety of your employees to get in. And depending on who trains, how they train, what that space looks like, you're going to create a plan. And it's either going to be a permit required plan or it's going to be a non-permit required confined space. But you should always follow the protocols given to you by your safety department. But there's nothing wrong with what you do. I see a lot because I do this every day. And I'll tell you this, I'd never go into a hole without calibrating an instrument. And I calibrate it. I hear too much. I hear way too much. So maybe I'm a nervous ninny and maybe I get paid every 2 weeks to talk about this stuff. But it's a lottery ticket. And you guys are playing in an environment that most people don't. You guys play with gas every day. And it may not be a gas pipeline, but you guys play with gas every day. You play with hazardous chemicals every day. So be aware of that. Don't take it for granted. Understand that the opportunity for there to be an issue is far greater than the normal people that we service every day in this industry. People have no idea what it takes to clean water. But I'll tell you, when the water doesn't come out of the faucet, who gets called? It comes pretty quick, doesn't it? So, just be aware. That awareness is probably the best thing. I did have one application not too long ago. I'm going to share, and then I'm out of here. Do I have 5 more minutes?
Yeah, definitely.
Okay.
If you have a question, once you're done, though.
Okay. I'll share this story with you because we'll install a piece of equipment in a location, and it measures the atmosphere. And if we get elevated levels on that device, it generally causes a concern for the owner. And the owner will go out and try to mitigate it. But if that value keeps returning, oftentimes they will say, hey, your device isn't working right. That very well could be. When was the last time you calibrated that, sir? Well, about a year ago. Well, you need to calibrate it. So we send out a service tech and he calibrates the instrument, and it calibrates just fine. He turns around and he leaves. 3 days later, the guy calls. He goes, hey, you just calibrated my instrument and I'm getting elevated levels. What did you do to my system? I calibrated it. I showed it 0 air, 20.9, and I showed it a known concentration of bad air. I linearized that sensor. Everything passed. Well, this thing doesn't work. I keep getting alarms. And if I get woken up at 2 o'clock in the morning again, I'm tearing the shit out and I'm going to put some new stuff in. Oops, I'm on YouTube. Okay, so they send out a service tech again. I'm not paying for this guy to come out here. You send him out here. Okay, you know what? Service techs ain't cheap. He goes out there, looks at the system, calibrates it again, digs in a little bit more, and he calls me up and he says, hey, John, I keep calibrating this thing and, it keeps going into fail mode. All right, did you check the wiring? No, I didn't. Okay, well, that could be a concern. So guess what? Now he goes out a third time. Wiring looks good, John. I calibrated it again. I'm doing this all on my own dime. I'm not doing this anymore. Your stuff's not working, John. What the hell's going on with RKI? Boy, man, I don't know. Well, better get somebody out here to look at it, because I'm not going to send my service tech out there to, X number of dollars an hour to do it. All right. Well, it turns out that in this particular instance, they had an H2s sensor. Yeah, they'd calibrate it, but about once a week when they get influent dumped into it, the amount of H2s would not only go from 0 to 100, it would go way beyond 100. And it would saturate that sensor, because that fuel cell is just a fluid reservoir. And there's so many molecules of hydrogen sulfide in there that it would set every alarm off, and it would shoot that value up to the roof, and it'd ring every bell that he had. So even when he went in there and he opened the garage door and he blew that out, the meter was still reading high because it saturated that cell. It was so high, it went beyond the dynamic range of the sensor, and it took 3-4 hours for that fluid to express all of the H2S out of it. Now that's an incredible story, because by God, how can you have that much H2S in a given area? He has an issue, one that extends beyond the dynamic range of the sensor that we consider from a safety perspective. But there was nothing wrong with our system except that it was being saturated by. So what we need to do is engineer in some mitigating circumstances. Hey, when you get to this level, you need to turn on a fan, you need to open up a garage door, you need to get that stuff out of there. But the equipment was working right. It's just the application and what was happening during this specific time and during that period was far exceeding any limits that are designed for the fixed gas detection system itself. So all this angst and all of the tough conversations that I had proved that the system was working right, except that the application itself was throwing curveballs at the owner of the facility. And everybody looks to the equipment to be not accurate, rather than, hey, it's influent and there's no controlling it. So we have to take critical looks at what is happening in our facility. A great thing to do is go in there with a portable unit and understand what's happening. If you calibrate your portable unit and you go in and it goes off, and then you come out and it goes down, but you see that your other instruments are reading high, these are all clues. We become a little bit of a CSI investigator. But don't kill the messenger. Hey, I calibrated the unit. Well, the alarm went off. Okay, let's dig a little deeper. If you want my guy to come back out there, they're going to charge you, man. So knowing your facility and what's happening within the facility, sharing that information with me is really important, because if my equipment's not working, we're going to fix it, because I want to earn your business for the next opportunity. But you also have to be aware of what is happening in the surroundings that you have as well. What was the question?
So I had a question. What was the Green Bay score last weekend?
Oh my God. Yeah, Aaron Rodgers, 0. Jimmy Garoppolo, who was going to get fired if he lost, he got a win, and now he's going to get a huge payday. Yeah, $46 million payday for that guy next year. You think he's going to be in Green Bay? No. Holy mackerel. Great question. Bears is a soccer team, right?
I'm serious.
I know.
I did get that. I get off the stage.
Yeah. No, hopefully the information I gave you guys was good. And you know what? I know it's oftentimes overlooked is the wrong word to say, but a lot of times we take for granted the jobs we have to do every day. But be aware of what your job duties are and the positions they put you in, because there's always unknowns, especially in municipalities and work. And whether it's trenching out, replacing water mains, warming your car up in the garage before it gets outside. I mean, you're pushing carbon monoxide all over the place. I mean, all these things add up, let alone wastewater treatment. I was telling Hunter the other day that in one of the press rooms we had ammonia, high levels of ammonia. I'd never seen that before. There's still a lot of things that I don't and haven't seen. So as I encourage all the people that I work with, I said, go in there and listen. Listen to what's happening, and oftentimes I'll get a request and say, yeah, I need a gas meter. Great. That means nothing to me. You got to be specific. I need a confined space meter. I need a meter that'll measure chlorine. I need to measure ozone. I need to measure ammonia. I have a lift station. I have an issue in my press room. Those are all things that help us. And I know that people are trying to commoditize this equipment. You can buy it almost anywhere, but you're not going to get the professional support and service that you need unless you buy it from somebody who's been trained. And that's why we work through local distributors. And that's why we don't take orders at RKI at the manufacturing level. We push everything through responsible service techs that we train that can show up when you need them and not have me say, well, I live in Wisconsin and I'm not going to be in Ohio until 8 weeks from now. So that's really the reason why we choose partners.
So John, let's say a company around Peoria would like to buy some monitors off of you. Who is the contact? Is that monitor?
Yep.
Depends on the business that we're in. Okay, like as John, I mean, like we don't get involved with fire, right? We don't get involved with, maybe you could speak on actually.
I can.
I guess what I'm asking is for the people that are on YouTube, if they are interested in getting a hold of you, who should they contact?
First and foremost, they can contact me through our website. It's the www.rkiinstruments.com. There's a page on there for asking to be contacted, and they'll put a little notes area. And Hunter has the ability to sell anywhere he wants because he's an authorized distributor for RKI. When I set up my distribution networks, and I don't mean this in any way to be exclusionary, I have to look at different markets. Fire service is a big market. Industrial is a big market. Wastewater is a big market. Agriculture is a big market. And I know that some people are really dialed into water, wastewater, and municipal business. Municipal business and pumps and those things are things that GAI does quite a bit. So they are a good broad-based distributor for me, and I'm confident that if I get a call from somebody in Peoria and they say, hey, yeah, I've got a trench, or I've got a vessel, I've got a boiler, I've got an XYZ, I've got a process. We are not selling wastewater treatment. We are selling atmospheric monitoring, and the equipment is always the same. So as long as Hunter and the GAI guys, they have different categories within their business as to who gets to do what, they will pick and choose who to send out. And their bandwidth on understanding gas detection will direct them to the same spot that they are with wastewater. That is, I don't care what it is, it's a widget maker, but if it's off-gassing X, Y, and Z, if I can measure it, we're going to measure it. So it's a great question that any RKI distributor that's trained by me should be worth the salt of a phone call. But there are some people that are better at things than others. GAI is dialed into fixed systems and portable equipment. I have other distributors that are better at portables and only sell portables because they don't have the service side that fulfills everything. So if I know that it is, I'll direct. And really, I'm a air traffic controller. So yeah, have them call. The contact here is Hunter. Have him call Hunter. He'll direct them to somebody else in his facility.
They can reach out to me, and then I'll
Yeah.
get it to the right person.
The best salespeople in the world are service guys. You know that, right? Because nobody tells the truth to a salesman. I mean, they don't. We show up and we give pens away, and they look at you like,
We like hats here.
Yeah, there you go.
What about mouse pads, man? I gave you
Yeah, the mouse pad's pretty cool.
taking that back. BS.
Yeah, it's the open communication and the ability to listen. That's the most important thing that we try to get across to people. But hey, the other thing is this. If you have gas detection now, don't be afraid to reach out to Hunter. Calibration services, and if things need to be fixed, worked on, changed out, swapped out, they have power on one side and they have a sensor on the other. Sometimes you put a controller in the middle. I can work generally with existing infrastructure, so you don't have to pull new wires and things. But find that service agent who is going to service you. Because oftentimes I'll walk in and they're like, yeah, that hasn't worked in years. Well, it was there for a reason. I mean, honestly, it was there and it was working for a reason for a while. So. I don't even have my website on there. Darn. Well, thank you for your time. I do appreciate it. If you have any extra questions, I'll hang out for a little bit.